B.Sc second year students of analytical chemistry. In last lecture we have learned about the estimation of main constituent in the hematite ore, that is we have already learned about the estimation of that is SiO2, a combined oxide, that is R2O3, it is the separate Fe2O3 and Al2O3, as well as MgO, CaO. So in today's lecture we are going to estimate the main constituent in the pyrolusite and the bauxite ore. So let's begin with the pyrolusite ore. Pyrolusite is the ore of manganese. That is what pyrolusite is, an important ore of the manganese. Pyrolusite is an manganese dioxide MnO2 ore what occurring naturally. The main constituent of the pyrolusite ore are MnO2, SiO2, Fe2O3, Al2O3, calcium oxide, magnesium oxide. Then analysis of pyrolusite ore. After sampling of the ore pyrolusite, the ore is dissolved properly by fusion method in flux treatment method of the dissolution. We have already learned about the how this fusion method is used, or how this flux method is used. So 1 gram of pyrolusite ore is mixed with the 3 parts, that is 3 gram of flux, that is nothing but fusion mixture KNO3 and Na2CO3 in a platinum crucible, and then solid mixture is fused or heat to high temperature at what the 1000 to 1100 degrees Celsius in a thermal furnace till a clear molten liquid is obtained. Then it is cooled to get a soluble solid mass. Then the solid mass contains soluble salts of the ore is dissolved in water with the help of little dilute HCl, and solution of ore is obtained. So what is the fusion method? That is what the fusion method. It is simple, that I am repeating once again. What 1 part of 1 gram of pyrolusite ore is mixed with the 3 part of the flux KNO3 and Na2CO3. That is fusion mixture in a platinum crucible. The solid mixture is fused heat at a high temperature, that is what the 1000 to 1100 degrees Celsius in a muffle furnace till a clear molten liquid is obtained. Then it is cooled to get a soluble solid mass, and then this solid mass containing soluble salt of the ore is dissolved in a water with the help of little dilute HCl, and solution of ore is obtained, and this solution is used for the analysis. So the silica SiO2 in the ore remains undissolved, and remaining all other metal salts in the ore dissolved to form a respective metal ions. So Fe plus 3, Al plus 3, Mn plus 4, Ca plus 2 and Mg plus 2. This solution is used for the estimation of all the constituents in the ore. The analysis of the ore involves the following estimation. What we'll have to do for the estimation of this ore is the estimation of SiO2, estimation of Fe2O3, Al2O3, estimation of Mn plus 2, and estimation of calcium and magnesium oxide, that separately. But you have already learned about the estimation of the SiO2, Fe2O3, Al2O3, as well as CaO and MgO in the hematite ore. Similar methods are used, but in the pyrolusite ore, the estimation of only Mn, that is manganese, is very important. So we are going to analyze the Mn plus 2, that is manganese, in the pyrolusite ore. So what is the principle? The method is based upon the titration of titration of the manganese second ion with the potassium permanganate, that is KMnO4, in neutral phosphate solution. So potentiometrically using platinum calomel electrode system. So what is the reaction is there? 4 molecule of Mn plus 2 plus MnO4 minus plus 8H plus 15H2P2O7 minus will get the complex of what? MnH2P2O7 thrice minus 3 plus 4H2O. So The volume of the potassium permanganate KMnO4 used is proportional to the amount of manganese second in the solution of pyrolusite ore. In this reaction, what happened? The reduction of manganese takes place. So what happened? The complexation reaction is occur, and the volume of the potassium permanganate required for the what the proportional to the amount of Mn second in the solution of the pyrolusite ore. So volume of KNO4 is equivalent to the amount of Mn second in the pyrolusite. So hence from the volume of potassium permanganate used for the titration, the amount and the percentage of the Mn second in pyrolusite ore is calculated with the formula percentage of Mn second pyrolusite ore is equal to what amount of the volume of KMnO4 in ml into conversion factor into 100 divided by weight of pyrolusite ore. So this is the formula for the estimating percentage of the Mn second. So method, an liquid, that is what the solution, definite volume of the Mn ore pyrolusite solution after dissolution by fusion method and after removal of undissolved SiO2 is taken in a beaker. Treat it with a sufficient 1:1 hydrochloric acid and concentrated sulfuric acid, and then add sufficient freshly prepared saturated sodium pyrophosphate solution to it. Then adjust the pH of the solution between 6 to 7, and then with the help of H2SO4 and by NaOH, dip a platinum and standard calomel electrodes in it and connect the electrodes to the terminals of the potentiometer. Titrate the Mn second solution against the standard KMnO4 solution, measuring EMF after each addition of KMnO4 till a solution till a sudden change around 300 megavolt in EMF is observed. Plot a graph of EMF versus volume of KMnO4 to the to obtain the endpoint that is volume of KMnO4 for the calculation. So what happened? Sorry, I have known this is what the 300 megavolt, it is not millivolt are there. So it is a simple potentiometric titration is there. What is the method for this? Is an liquid, there is a volume, sufficient volume, that is definite volume of the Mn ore is pyrolusite solution after dissolution by the fusion method and after removal of undissolved SiO2 is taken in a beaker. Treat it with the sufficient 1:1% hydrochloric acid and sulfuric acid. Then add sufficient freshly prepared saturated solution of that is pyrophosphate solution to it. Adjust the pH of the solution between 6 to 7 pH, that is with by using H2SO4 and by NaOH. Dip a platinum and saturated calomel electrode in it. Connect the electrodes to the terminals of the potentiometer. Then titrate the manganese second solution against the standard KMnO4 solution, measuring EMF after each addition of the KMnO4 till a sudden change, that is what sudden change around 300 millivolt in EMF is observed. Plot a graph of EMF versus that is volume of KMnO4 to be obtained the end point, that is V KMnO4 for calculation, and with the help of calculation we can able to calculate the amount of, that is percentage of manganese second in the pyrolusite is equal to volume of KMnO4 in ml into conversion factor into 100 divided by weight of pyrolusite in gram. This is about the analysis of pyrolusite ore, that is main constituent manganese, how to analyze the manganese from the pyrolusite ore. Next one is the analysis of bauxite ore. Bauxite is a ore of aluminium. So the important ore of aluminium are clay, bauxite and kaolinite, and etc. But the bauxite is the most important ore of aluminium. Bauxite is aluminium oxide Al2O3. The major constituent of the aluminum ore bauxite are Al2O3, Fe2O3, SiO2, TiO2, CaO, MgO, and MnO. Therefore, the analysis of bauxite involves the estimation of the following. So, estimation of moisture, estimation of SiO2, estimation of Fe2O3, Al2O3, and estimation of only Al2O3, Fe2O3. Uh, Estimation of only Fe2O3, estimation of calcium oxide, estimation of magnesium oxide. So how to make the samples of this ore? So sampling of the ore before the analysis of the bauxite ore is what carried out. The bauxite ore is a sample. So first the naturally occurring bauxite ore is crushed in a jaw crusher and hammer mills, and gross sample of the ore is obtained. So by grinding or jaw crushing or hammering, we what crush the given ore. The gross sample so obtained is further reduced in the particle size to 100 mesh size by pulverizing it in a ball mill and reduced in quantity by any one of the methods such as long pile, alternative shovel method, or coring and quartering method. So or by tabling, raffle splitting method, so or by the what the mechanical device. So uh, one of the one method is used for the reducing size of the what given uh, sample. So the laboratory sample of the bauxite ore so prepared is stored in the airtight bottle and it is used for the analysis. So storing is done in the airtight bottle. So determination of moisture, first constituent is the moisture. Weigh accurately about 1 gram of the bauxite ore sample in a platinum crucible. Place it in a oven contain what the maintain at 100 degree 105 degree Celsius till constant weight is obtained. Cool in a desiccator and what immediately weigh. During the heating at 105 degree Celsius, the moisture water present in the bauxite ore is expelled out. As a result, the ore experiences a weight loss which is equivalent to the amount of moisture present in the bauxite ore. Simply, it is what the how will you have to estimate the moisture content in the bauxite ore. It is a simple heating process is there. Moisture is expelled out after what heating it in the oven at about 105 degrees Celsius, and by weighing at a constant weight. If you get the constant weight, then take a weight, and what is the weight loss before and after weighing what the heating is determined is that the weight loss is nothing but what the loss moisture content in the given bauxite ore. From the weight of loss, that is the amount of moisture, the percentage of moisture in the bauxite ore is calculated. The moisture percent in the bauxite ore is equal to weight loss into 100 divided by weight of bauxite ore, or another one formula is there, amount of moisture into 100 divided by weight of bauxite ore. So in this way we can able to analyze the moisture or determine the moisture content in the bauxite ore. Second one, dissolution of bauxite ore by fusion method. 1 gram, 1 part of the bauxite ore is mixed with the 3 grams, 3 parts of the fusion mixture, that is Na2CO3 and K2CO3 in a platinum crucible. This 1:3 mixture of bauxite ore and fusion mixture in a platinum crucible is then fused in the muffle furnace is about 1200 degrees Celsius till a clear molten liquid is obtained. So same as that of the hematite and manganese, that is pyrolusite ore. The molten liquid is then cooled to form a solid mass. Then the cold solid mass is then dissolved in the distilled water with the aid of the little diluted HCl. After dissolution, all the constituents such as Al2O3, Fe2O3, CaO, MgO remains in the dissolved form, whereas SiO2 silica remains in the undissolved form. So, first one is the estimation of SiO2. In short, what happened? It is what simply the mechanical method, that is filtration method, is there. After dissolution of the bauxite ore by fusion method, the SiO2 remains in the undissolved form. The undissolved SiO2 silica is filtered through a Wattman filter paper number 41, washed with 2-3 portions of hot water, dried on hot cone, transferred to a pre-weighed platinum crucible, incinerated and ignited at 500 degrees Celsius in a muffle furnace till a constant weight is obtained. Uh, Cooled and weighed as SiO2 residue. From the weight of SiO2 residue, the percent of SiO2 in bauxite is calculated. So it is what simple method, simple what undissolved form of the bauxite is taken, that is what SiO2 is taken, and this washed and filtered with the Wattman filter paper number 41. Then it is what the dried and incinerated in the platinum crucible and finally ignited at about 500 degrees Celsius in a muffle furnace till a constant weight is obtained. Cool and weigh the SiO2 residue. From the weight of SiO2 residue, the percentage of SiO2 in the bauxite is calculated. So percentage of SiO2 in bauxite is equal to weight of SiO2 residue into 100 divided by weight of ore. So a second estimation of Al2O3 in bauxite ore gravimetrically. In the filtrate free from SiO2 is used for the estimation of Al2O3 in bauxite. The filtrate containing Al plus 3 ion is acidified with the acetic acid and heated to boil. To the hot solution of Al plus 3 in acetic acid medium, add sufficient oxygen in acetic acid reagent with the constant stirring. When Al plus 3 gets precipitated as the Al oxygenate complex, such as this, such type of reaction is there. Al plus 3 oxygen, 8 hydroxy quinoline is there. Then it what forms the complex with aluminum oxygenate precipitate is obtained. After getting this precipitate, the aluminum oxygenate ppt so obtained is digested for the half an hour by the gentle heating and allowed to settle. Filter the aluminum oxygenate ppt through a what the pre-weighed sintered glass crucible using a what the suction apparatus. Wash the oxygenate ppt with the very dilute solution of oxygen reagent. Dry the edge crucible with the that is sintered gas crucible with the aluminum oxygenate ppt in a oven at 110 to 120 degrees Celsius till a constant weight is obtained. Cool in a desiccator and weigh as a aluminum oxygenate. From the aluminum oxygenate residue, the percentage of Al2O3 in bauxite's ore is calculated. Then percentage of bauxite, that is Al2O3 in bauxite ore, is equal to weight of aluminum oxygenate residue into conversion factor into 100 divided by weight of bauxite ore. So in this way we can able to analyze the Al2O3 present in the given bauxite ore. Then second estimation of Fe2O3 by volumetric method. It is gravimetric method. Al2O3 is estimated by gravimetric method and Fe2O3 is estimated by means of volumetric method. The filtrate free from SiO2 is used for the estimation of Fe2O3. The above filtrate is diluted to a known volume in the volumetric flask. A known aliquot of the silica free pre-filter is boiled and a conical flask. Then to the hot solution of Fe plus 3 add drop by drop essential to solution till the yellow color completely disappear. When the yellow color completely disappear, reduction of Fe plus 3 to Fe plus 2 takes place. Then reaction occurs is what? 2Fe plus 3 plus Sn plus 2 to gives what the reduction of Fe plus 3 to Fe plus 2 takes place and oxidation of Sn plus 2 to Sn plus 4 takes place. Cool the solution under the tap water and add sufficient HgCl2 solution to what destroy excess added essential to sort for the what reduction what destroying of essential to add HgCl to solution, then add mixture of H2SO H2SO4 H3PO4 and solution and diphenylamine sulfonate indicator, then titrate the Fe plus 2 ion solution against the standard solution of K2Cr2O7 till the color changes from colorless to purple to violet. Then the titration reaction is given by Cr2O7 plus 6Fe plus 2 plus 14H plus gives 2Cr plus 3 plus 6Fe plus 3. Here what the oxidation of Fe takes place with the help of chromium, that is what potassium dichromate, from the volume of standard K2Cr2O7 consumed by a known volume of bauxite ore solution, the percentage of Fe2O3 in bauxite is calculated. So what is the formula for that? Percentage of Fe2O3 in the bauxite is equal to volume of K2Cr2O7 into conversion factor into 100 into molarity and divided by weight of bauxite ore, so molarity of K2Cr2O7. So next one is the estimation of calcium oxide. Filtrate free from SiO2 and R2O3 is used for the estimation of calcium oxide in bauxite. The above filtrate is heated to boiling and then to the hot solution. Sufficient volume of the ammonium oxalate reagent is added when calcium gets precipitated as a calcium oxalate. So what is the reaction? That is Ca++ plus ammonium oxalate NH4 twice C2O4 gives the calcium oxalate PPT CaC2O4 plus 2 ammonium ion. The resulting PPT, that is what calcium oxalate is digested, filtered through a Wattmann filter paper number 42, washed with the dilute solution of reagent, dried, transferred to the pre-weighed crucible, incinerated, carbonized, ignited at 700 degrees Celsius and weighed as a calcium oxide similar to the hematite ore. From the weight of the CaO residue, the percentage of CaO in bauxite is calculated with the help of percentage of CaO in bauxite is equal to weight of CaO residue into conversion factor into 100 divided by weight of bauxite ore. With the help of this formula, we can able to calculate the amount of or percentage of calcium oxide present in the bauxite. Next one is the estimation of MgO. The filtrate free from SiO2, R2O3 and calcium oxide is used for the estimation of MgO in bauxite. So the above filtrate is heated to boil to the hot solution Mg++ ion, add drop by drop with the constant stirring sufficient amount of ammonium hydrogen phosphate, that is NH4 twice HPO4 reagent. When Mg++ gets precipitated as magnesium ammonium phosphate, that is Mg plus 2 plus NH4 twice HPO4, that is ammonium hydrogen phosphate, gives magnesium ammonium phosphate, and this magnesium ammonium phosphate PPT is digested, filtered through a Wattmann filter paper number 42, washed with a dilute solution of reagent, dried, transferred to a pre-weighed crucible, incinerated, ignited at about 700 degrees Celsius to 800 degrees Celsius till a constant weight is obtained and cooled and weighed as a magnesium ammonium phosphate. From the above magnesium ammonium phosphate residue weight, the percentage of magnesium oxide in the bauxite is calculated with the formula magnesium oxide percent in the bauxite ore, so is equal to weight of magnesium ammonium phosphate residue into conversion factor into 100 divided by weight of bauxite ore, that is nothing but bauxite ore. So this is about the estimation of the magnesium in the bauxite ore. So this is sufficient for today's lecture. If you have any queries regarding the analysis of that manganese in the pyrolusite ore as well as the analysis of main constituent in the bauxite ore, that is nothing but calcium oxide, magnesium oxide, aluminium, as well as the Al2O3 as well as Fe2O3, SiO2. Then please comment your question in the comment box, YouTube comment box. Thank you, thanks a lot, have a nice day.